All right, hello. Me and my team here are here to introduce you guys to Arduino. Arduino, the only time being selfish is encouraged. So this is the team.
I'm Craig. I'm Hedra.
I'm Alex1.
Alex2.
All right, so 1 second. So for this project, we got our inspiration from a game that was invented around 2500 BC, the original Go from China. And the goal of the game is to surround more territory than your opponent. So that's where we found most of our inspiration for our designs.
So, Arduino Go is, as we said earlier, it was like inspired by the original one. And what we did was we took that idea and we made it digital. And by doing that, we had capture points where it's a two-player head-to-head game. And with the two NeoPixel rings are synced at the same time, you will be able to play with each other. And the objective of the game is to capture as many spots or LED points as possible within a time limit, which we've set at 1 minute. And you can overtake each other's LED spots, and the two radios we have with the Zigbee radios, they communicate in sync, so everyone will be able to see everything at the same time. So here's a demo that we've recorded.
All right, so that's our Arduino. Just to give you guys a little taste of what it's like to play it, which you guys will all be able to do a little later. But the process, so as we've been saying, we've been using Arduinos. Arduinos are small computers that you can upload with software and attach hardware. They're slightly limited, but you can do very powerful things with them. The NeoPixel ring, so the thing that we've been talking about the most and probably the biggest part of the game, is literally just this. It's a 16 LED ring, and that's, what controls, or not what controls the game, but what gives you the visual for the game.
So instead of using other wireless technologies like Bluetooth and Wi-Fi, we've decided to go with the XB. The XB is a low data rate, which means low speed, but also low power. And since we run it through battery, we need low power. So this actually fit our purpose, and nothing else could have beat it really. And in addition to that, the proximity of it, the range that was given for the wireless technology was ideal for our situation. So why XB and why not Wi-Fi or Bluetooth? Well, XB has a lot of pros to it that really weighed heavy compared to what Wi-Fi and Bluetooth provided us with. So as you can see with the chart, first off was that for power, Zigbee or XB were the least power consumption devices that we can have used. Next up would be Bluetooth, but Bluetooth only has 10-meter range compared to Zigbee's 10 to 100 meter. And in addition to that, the data rate, even though Bluetooth had 1 megabit per second data rate, we really did not need that high of a speed. So at the end, we all decided to use Zigbee instead and not Wi-Fi or Bluetooth.
All right, so we designed a little bit of a flow chart for you guys just to visually give you an idea of what happens. So when the button is pressed, it initiates the program. The Arduino launches the game, and then the XB sends the data between the two rings. So that's a really watered down version of what happens. So we had like probably more than 99 problems, but this is a list of, you know, the largest challenges we had when designing this product. We did overcome most of them. So the first one, storing the LEDs. We needed to find a way and find a data structure that can store these LEDs in a way that was easy enough for us to access them and have the software access it. And we did that real simply by just using an array. That was the quickest way and the most efficient way. Dealing with bounce. So for those that aren't familiar, bounce is when the human, so us, we are a lot slower than the software. The software is always going to be miles ahead of us. So we needed to program around that. When we would press a button, the software is, you know, like I said, miles ahead of us. So we needed to find a way to slow that down, slow the software down to human speed. And we did that real simply by using a while loop, which would keep, when somebody presses the button, it basically just pauses the program and says, hey, wait for the human. Relaying the information between the XBs. At first, we thought it was going to be real simple. As we progressed, the information that we needed to transfer between the two seemed to be a little bit more difficult than we had first imagined. But eventually, we had figured out that the best way to do this was to strip out the packets that were being sent between the two XBs and only take the information that we need and to ignore any other jargon that was transferred in between them. Putting the product into something that was compact enough seems real simple. There's a lot of different materials we could have used, but we went with a simple cardboard box design, as you can see there. And then making sure that everything was synced up perfectly was another challenge that we had overcome.
So finally, market. Who has something like us? Microsoft doesn't, Google doesn't, and Apple does not either. So we couldn't find anyone or a company who would create something like this. We were the first that we are aware of. For production purposes, it can be made something more high-end, more quality-like, and more professional. And no company has created something like this, so there is a market for it. It's unique, it's new. People and kids would be interested for it. So there is good potential for this product. And that's Arduino Go, guys. That's our game we've created from the scratch that we were inspired by the original Go board, and that's that.